students, you are welcome again to MTH102 Elementary Mathematics 2 class. Today we are going to consider limit of a function. A limit of a function, it is an important concept in the study of calculus. Which calculus? It is the study of differential and integral calculus. Limit of a function is very important so that we shall study it in various aspects. 1. We shall study the definition of limit of functions. 2. We shall study it numerically and graphically. 3. We shall study the notation of limits of functions. Then we shall now consider the theorem of function, which will help us to solve problems on the limits of function. We shall consider all this in this class. Thank you. Till meet in the class. Hello. We are considering limit of function here. If you look at my left hand side, you see that we have table, and this table we have s and we have f of s. S have its value, f of s have its value. In this table we have x value called input, while f of s value is called the output. We can see the input approaching 4 from the left. If you look at down, we can also see that input approaching 4 from the right. The word approaching or tend to shall be used in this class. I'm still Dr. Jisu Akim Babatunde. Let's move on to today's class. Today's class is limit of function. One important aspect of the study of calculus, it is the analysis of function value or y output, like I mentioned, change as input value. Today, we shall study the fundamental notation of limit of function. Suppose that we have a function f is given, and suppose we have the value x value is given. As s is getting closer and closer to some number a, if the corresponding output, that is f of s, is getting closer and closer to another value, then the number is called the limit of f of s as approaching a. Approaching or tend to will be commonly used in this study because the limit is saying approaching, getting closer. If, for example, you have f of s is equal to s minus 2, and we select the value, s value that get closer to 4. In the table and the graph in the next slide, we shall see that as input value, that is s approaching to 4 from the left, and the output value approaching 11 from the right. As we say, as s approaching 4 or tends to 4 from either side, the function of f of s is equal to s plus 2 approaching 11. We say either side can be from the left side or from the right hand side or right side. We are now studying the limit of function numerically and graphically. And the function we are considering here is f of s is equal to 2s plus 3. Let's study it numerically. Numerically, we have s, and in the table we have f of s in the table. When s is 2, if you see when s is 2, 2 times 2 plus 3 will give us 7. When s is 3.6, if you put this value here, that is input value, if you put it in 2s plus 3, we are going to have 10.2. When it's now get to, that is, it's now approaching 4, 3.9, we have, when we put it in the function f of s is equal to 2s plus 3, we have it as what? As 10.3. If you have 3.99, if you put it there, we have 10.98. If you have 3.999, we have 10.99. You can see that as the value of s approaching 4, the limit of f of s is approaching 11. If you study it from the right hand side, we can see 4.0, and 4.0 is 11. So 4.00 is 11. 4.00, I mean 11.00, we have it is also 11. As we have 4.01 is also 11.0. As we have 4.2, 4.1, we also have it at what? 11.1. That is, as approaching 4, the limit is 10 to 1. You know, the arrow indicate that. In the left is going up, going up, the value is going up. You can see the arrow going up when that is approaching 4. In this one, is going down, the arrow is going down. It's telling us that is approaching 4 at left hand side. You can see left, you can see, you can look at the arrow facing. This output is also approaching 11 here. The output is also approaching as it's moving up. Let's see the graphical form of it. Let's say we have graphical. When it's 2, we have it around 7.7. We have it 7 point. When it's 2 point, when it's, let's say this 3, when it's 3, we have it as 9, as 9 point something. When it have exactly 4, it's now what? 11. You can see arrow show that as it's getting to 4, it's approaching 11. From this, look at the arrow from left. Do you get it? It's approaching 4. From the right, it's also approaching 4. We are getting 11 at the value. That's it. The arrow represents approaching or tend to. We can say it's representing approaching or tend to. And this statement, the statement above calculating as s tend to 4, 2s plus 3 is equal to 10 to 11. That is, if you substitute 4 in 2, we are going to have 2 times 4, 8 plus 3 give us 11. In abbreviation, it can be abbreviated as the limit of f of x, that is the limit of s plus 2 10 to 4 or approaching 4 is equal to 11. The definition, the major important here is the word approaching or tend to. As s approaching a, look at it, the limit of f of s is L. That is, as limit of f of s tend to a is equal to what? L. If the value of f of s are close to L, for the value of y that are sufficiently close but not, it should be important to know the word not equal to a is approaching, is getting about a, not a. The limit L must be a unique real number. That is, must be a real unique number. We can specify the side, either from the left or from the right, approaching the value s, approaching the value a. Look at it. If we have limit of s as s tend to a raised to power minus 1, it means from the left. That is, a here is less than, s here is less than a. If we have limit of s as s tend to a raised to power p, it means from the right. That is, where s is greater than a. Is that taken? the theorem. The theorem of limit of limits of function. As s approaching to a, the limit of function f of x is L if the limit from the left exists and the limit from the right also exists. Both must be the same. That is, both must be equal because before you can have limit. And if you have it here, limit from f of x is equal to limit of f of x from the left and from the right must give you L before the limit of f of x as s tends to a is equal to L before it can be exists. For example, let's solve this little problem to consider what we are saying. Find the limit of find the limit limit x squared plus 1 as s tends to 0. When you say approaching here solution we are going to substitute directly. That is, where we have x, we put it 1. And if you put it 1 square plus 1 as s tends to 1 will give you 1 square plus 1. 1 square is 1. 1 plus 1 is what? Give us 2. To example 2. This example 2 is very unique. We have to study it critically so that we can understand what we call limit of function. Let f of x is equal to x squared minus 1 all over x minus 1. What is f of 1? If we substitute directly f of 1 here, we have 0 because 1 minus, if you put 1 in x, we have 1. If you put 1 in x squared, we have 1. 1 minus 1 is 0. 1 minus 1 is 0. This denominator is 0 is what? 0. When denominator is 0, that means the function is undefined. That is, we can simply summarize it as f of 1 here as a result of this function does not exist. But if you look at graph here, we can see that we have value, other value except what? 1. We don't have value of 1 here in this graph. That is, when it is 1, there is no value for it. Let's proceed. Solution, be part of it. What is limit of f of x as x tends to 1? This one can be achieved in numerically and graphically also. If we select the x value close to 1 on either side, and we shall see that f of x is closer and closer to 2. Let's see the table below. Thus, the limit of f of x as x tends to 1 is what? Is 2. Is 2. If you look at it here, the limit of f of x as x tends to 1 is 2. Look at it. When x is 0.9, we have f of x 1.1. When it's 0.99, it's 1.99. And when it's 0.999, it's 1.99. It can be approximated to what? To 2. That is, it's getting closer to 2 as 1 is getting closer to 1. As s is getting closer to 1. If you look, this is the left hand side, this is the right hand side. As you have 1.11, if you go 1.11 like this, we start, this one will be going up. This one will be going down. This one 1.11, we have 2.00, 1.1, 1.01, we have 2.01, we have 1.11, we have 2. That is, as is getting to 1, the limit, the f of s also tend to 2. Limit property is very important to understand the limit properties so that we can able to solve the problems regarding to limit of function. If limit f of s, let limit f of s is equal to L as s tend to a, and let limit g of s is equal to m as s tend to a, and c is constant. Constant means ordinary number. Then we shall have the following. The number one limit property, the limit of a constant is constant. Look at this example. The limit of a constant is constant. Limit C as S tend to A is give us C. Then when you have limit of power is power of that function of that limit, and that limit of root is also the root of that limit, assuming that A is a positive, n is a positive integer. If you see it, we have limit into square, we give us this. That follow the limit property. If you consider the sum or difference of limits, we have it here as limit of s tend to a f of f either plus or minus. We give limit f of s as s tend to a plus limit g of s at s tend to a will be L plus or minus m, because our limit of g of s is m. We stated it in the initially when we are considering the property of limit. The limit of a product is the product of the limit. If you see it, limit of g f of s dot g of s product, we give you limit f of s as s tend to the dot limit g of s as s tend to a, which is L dot m, which is what product. The same thing with the limit of a quotient, which is the quotient of function. We have it like this as in 5. You can see clearly in 5 that showed the product, the quotient of limit of function, and we can have it as L over m. Let's the theorem on limit of rational function. What we call rational function, we have to take it for any rational function with a in domain of f. Look at it, the limit of capital F of s, we use capital F of s to mean a rational function, then equal to f of a as s tend to a. Rational function have a family of common function, including all the polynomial function and ratio compute function. That they call rational function. And in this class, we have to know the definition of rational function so that we can apply it everywhere or anywhere we see it. Look at this example 2. Example 2 says find the limit of s raised to the power 4 minus 5 s raised to the power 3 plus s squared minus 7 as s tend to 2. Here we are going to substitute directly. Is that taking? We are going to substitute directly. When we substitute directly, look at this. We have s raised to the power 4 minus 5s raised to the power 3 plus s squared minus 7. Where we see s we replace by 2. When we have s raised to the power 4, we become 2 raised to the power 4 minus 5 times 2 raised to the power 3, which is s raised to the power 3 plus s squared. This will become 2 squared minus this. And s raised to the power 4 give us 2 raised to the power 4 give us 16. And when we have 2 raised to the power 3 is 8. 8 multiplied by 4 by 5 I mean is what? 40 plus 4 minus 7. And if we add this together, the result we are going to have is going to give us 7. It's going to give us minus 27. It's going to give us minus 27. This leads us to example 3. Example 3, find the limit of square root s squared minus 3s plus 2 as s tend to z. This also we also substitute directly. When we substitute directly, where we have s squared, we put 0 squared. Where we have s, we put 0. 3 times 0 plus 2. 0 squared is 0 minus 3 times 0 will give us 7 plus 2. The answer will give us what? Root 2. Let's consider this beautiful example 4. I call it beautiful because it's going to tell us the unique way of solving the rational number, and this can be this will help us because not all the function that doesn't exist that we cannot have the limit value of it. Let's consider the example. Let r of s equal to s squared minus s minus 12 all over s plus 3. Find the limit of r as s tend to minus 3. Then the function of r minus 3 does not exist. Why? Because if we put the value of minus 3 here plus 3 here, this will give us what? Undefined. This doesn't mean that the limit is not exist because the limit is getting closer and closer to minus 3. It's not mean exactly minus 3. Let's move on to see how we are going to solve it graphically, and we can solve it. After this, we move to algebraic form of it. If you see, we have r of s give us s squared minus s minus 12 plus 3. Then, if you study it like this is from left, and the limit is getting to 3 minus 3. You know, when it's minus 3.1, is much more lower than minus 3.01. You get it's much more lower. As it's getting to the minus 3.1, the r of s is also getting to 7.1. If you substitute the value here, this is what we are going to have. Then as it's getting to minus 3.01 is, yeah, r of s is closer to 7.01. At is getting closer to 3.001, the r of s is getting closer to 0.001. Then to the right hand side, look at 2. When we have minus 2.9, we getting closer to 6.9. When it's getting closer to minus 2.99, it's getting to 6.99, minus 6.99. When you get to minus 2.999, it's getting closer to 6.999. That is, it's getting closer to 7. That is, the limit of r of s minus 7 is equal to minus 7 as I tend to this approach. That's why it's not say when the function doesn't exist, it's not mean we can have limit. We can have limit, we can provide answer numerically or graphically. The graphical aspect of it. The graphical aspect of it, if you see it like this, when it is minus, look at the arrow, it's getting closer to minus 7. If you see, this s here, y here is positive, y here is negative, s here is positive, s here is negative. This, if you see the arrow, as it's getting to this, it's giving us 7. As it's getting to this by the left arrow, as getting to minus 1, it gives us 7. Let's move on to algebraic. We have algebraic form of it, and we call it limit algebraically. That a function that is a function r of s is by is simplified by factorizing the numerator, noting that the factor s plus 1 is present in both numerator and denominator. As long as, look at that statement, as long as s is not equal to minus 3, the expression can be simply simplified as this. We have s r f of s is equal to s squared minus x plus minus 12 all over 3s. This can be factorized. If you factorize this, if you don't know factorization, we have to go and revise on our factorization. Factorization is what we done in our elementary class, our secondary school. We have to know it. The factor of this is s plus 3 into bracket and s minus 4 into bracket and is over s plus 3. Then s plus 3 can cancel s plus 3. We now have it as s minus 4. We now say 4s not equals to minus 3. Is that taken? Then when we now solve the problem limits of s minus 4 as s tend to minus 3 will now be, if you put the value of minus 3 will now give us minus 3 minus 4 is equal to minus 7. That's how we solve such function algebraically. We consider the problem and we are able to use theorem of limit of function to solve problem. In the class activities, I want each and every one of us to solve the problem, to solve the to solve this problem display by the at the end of the class. I want everybody to submit the solution to me. Until then, I want to thank everybody for listening, for participating in this class. Thank you. We shall meet on the facilitation class. Thank you, everybody.